Okay, so let me show you how I would be answering these questions. The first thing we need to look at is this, inefficient. Inefficient basically means that the code could be made smaller. So if you didn't know this, write this down. That we can make the code smaller. But not just smaller, let me just move this way out of the way. What other things would inefficient mean? Less processing for computer or for the CPU. So let's imagine that you have to print out a message over and over and over again. That is more than just printing it out once in terms of the amount of stress it gives to our CPU. So is there anything in our code where we can print out once instead of over and over again? Also, inefficiency could lead to errors in code or errors, runtime errors. Now we know that runtime errors is the code will run, but it will crash during our program. An example would be, using int, but we enter in a string instead, it will crash it. Another error we need to look for is logical errors. Is there anything which could make the program not run the way it's meant to run? So let's have a look at all of this. So to begin with, is there anything which we can do to make our code smaller? Well, the first thing I'm going to look at always is the type of loop. Now I can see this as a repeat loop. Now the problem with a repeat loop, if we did that as programming, is it's quite big and we can make this loop smaller. So we can use a for loop. Now this repeat loop is counting until 10. And the best loop to use if we want to do counting until we get to a certain number is actually a for loop. So I'm going to put replace repeat loop with a for loop, as it requires less code, which means our code will be smaller, which means it'll take up less memory when we save it and run it, and less stress on our CPU. The second thing we're going to change is this print. So every time this loops, we're going to print out the total every time. So it's going to print out, keep printing out the total. But actually, if you look at what the instruction says, we want to print out the total at the end. We want to input 10 numbers and then output the total. This is going to output the total every time. So we're not doing what it says here. We're being naughty. Not good. Now, if this said it wants to print out the total after every time, then we have to leave it in. But as it says it wants to do after we enter in the 10 numbers, we're going to move it from line 6. So move print total from line 6 to line, well, underneath 8. There we go, and that will basically mean less processing power for our CPU. Our CPU has to work harder, it has to keep printing out total all the time, 10 times. But in fact, we can do it so it only does it once. That means less stress for our CPU as well. I'm hoping that makes sense. Now, the final change what we can do is not to do with any mistakes or anything, but it is possible for the person using the program to input a number which is not positive. They could enter in like -4. There's nothing to stop it from happening. This program needs it to be positive numbers. So this would lead to a logical error because it will run but not the way we want it to run. So what we need to do is add a validation rule. Such as like a range check to stop or prevent, I'm going to use prevent, user entering a negative number. There we go. This would have got me 3 out of 3. So how can I turn this into code? Well, we still want total equals 0, but we no longer need counter. You only use counter for repeat and while loops. So I can go straight into it. For I in range, and we're going to do it 0 to 10, do. Remember, we're doing pseudocode. And what is it that we want to do? Well, we want to basically make sure that we're entering in a positive number. So look what I'm going to do now. I'm going to do input num. Now my input should be really capital letters, like it is here in pseudocode. That'd be naughty. I'm sorry. And then I'm going to do a while loop. While num is less than 0, do input number again, because we don't want a number less than 0, so we're going to keep repeating this until we enter a number which is greater than 0. And while, because you're going to do that in pseudocode. And then we want to do our calculation, which is total equals total plus num. So total equals total plus num. Now, when you do pseudocode for a for loop, you need to do next I, which basically says now go up by 1. It's like count equals count plus 1. But in real coding, you don't need this line. This is like count equals count plus 1, loop onto the next number. But you do need to show it in pseudocode. Then I'm going to do an end for. And then I'm finally going to do print total. And there we have it. That is these 3 things turned into code. If you if you still don't understand this, you need to let me know by email. If you do understand it, add it as a target and assign it to redo this question. Okay, so now we're going on to trace table, which may have confused you. So let me show you how I would do it. So first of all, I need to -1 equals quit. So I know that whenever I see -1 in my data, it's going to mean quit, and I'm going to put a little box around it. Quit. Easy. The second thing I'm going to do is work out what it is that I'm going to have to input into my trace table. So I've got height, width, doors, and windows. So 4 things. So what I'm going to do is I'm going to group these into 4. So this would be windows. So height, width, door, and window. So let's just group this as 1, 2, 3, 4, 5. Nice and easy so far. So we know that we've got 0 and 0 here as our first inputs. Well, these are already set in the program. We're assigning 0 to these variables. 0 and 0. We now want to input our height, width, door, and window. So it's 3, 5, 1, 0. Nice and easy so far. Now, we come up to the calculation. So let me show you how you do this. I'm going to put a bracket around the multiplications. Okay, this is the first thing you do. This is the second thing you do. This is the third thing you do. This negative is the 4th, and this is the 5th. So So you've got 5 things in our calculation. You do this multiplication first, then this multiplication, then you add area to this answer this. You then take away that total by this answer here. You then take away windows by that. So if we were to do that now, we would have height times width, which would equal 15. So if I was to do this here, we would have area equals area plus height times width. 3 times 5, which would equal 15. Okay? Making sense so far? Good. I'm glad it did make sense so far. So, what do we want to do next? Well, we want to do the same for doors. So, I'm going to then, it should be take away. And then we've got door times 1.5 take away win for windows. So door is, the value of that is 1 times 1.5, which equals 1.5. We then add, so I'm going to put 0 plus 15, which equals 15. So area, height times width, all of that will equal 15. So I'm just going to do 15 down here. 15. And then what we're going to do is take away 15 by 1.5, which should equal 13.5. So we've taken away this 15, which is basically this, all of that, and we've taken it away from this, which is equal to 13.5. We then need to get 13.5 and take away whatever the value of windows is. Windows is 0, so if 13.5 take away 0 equals still 13.5. So that is the area of this. So we then loop back to the top. We then input the next numbers, which is this group. 3, 7, 0, 0. We can leave this blank, or we can put a 0 here, it makes no difference. Okay. And what we want to do is we're going to work out the next area. So we simply do the same again. It's going to be height times width, which is going to equal 21. Okay, we're then going to plus it to area, which is going to be 21 plus 13.5 equals 34.5. Now, as these are zeros, it's not got any more impact on our calculation, so the answer is going to be 34.5. This is a 0. Now, we enter in the next group. So we go through the flowchart, we enter in the next group. So the next group of numbers go as 3, 5, 0, 3. Nice and simple. On the flowchart, is height -1? Well, no, it's 3. So we carry on, we go down to the calculation. And then we do our calculations again. So 3 times 5 is 15, so we've got that. We then add that to the area. 15 plus the area is 49.5, so that's nice and easy. Then this is going to be 0 because doors is 0, so if we're still on 49.5. Just going to put that here. And windows is 3, so we're going to take away 3 from 49.5, which equals 46.5. Okay, we're still on tins as being 0. believe. Yep. Okay, we're now going to enter in our next group of numbers, which equals 3, 7, 1, 1. So all we have to do with this is 3 times 7 is 21. 1 times 1.5 is 1.5. So let me just write these down. So we've got 3 times 7 is 21. We've got 1.5 from our calculation. We're going to add 21 to our current area, which is going to give us 67.5. We're then going to take away 1.5 from here, which is going to basically equal 66. Take away 1 from Windows, which is going to be 65. So we've got 65 here. That's our new area after following these steps. So we then enter in the next numbers, where this is going to be slightly different, ladies and gentlemen, in terms of where we're going next. Now I'm going to have to stop this video to give another video because I've gone over the time limit. I'm on 16 minutes. So in order to see what happens next, tune in for part 2.